The quiet revolution that began with Rolls-Royce's engine concept was now gaining unstoppable momentum. What had started as a technical curiosity had turned into a political wave, reshaping how nations thought about defense collaboration. For decades, Canada's air power story had been about adaptation, about flying other nations' aircraft, adopting other nations' strategies, and accepting the invisible constraints of alliance politics. But now, through the Gripen and Rolls-Royce partnership, that story was changing. It was no longer about dependency, it was about design. The deliberate crafting of a future where autonomy, innovation, and intelligence coexist. Inside the Defense Research and Development Canada laboratories, engineers were analyzing test data coming from Europe. They saw something that thrilled them: energy efficiency metrics that broke expectations, thrust-to-weight ratios that hinted at unmatched performance, and most importantly, maintenance profiles that aligned perfectly with Canada's logistical philosophy. The Gripen RR prototype wasn't just performing, it was redefining what operational sustainability could mean for a modern air force. Unlike the F-35, which demanded complex supply chains and constant software updates from a centralized hub, the Gripen RR could be maintained locally. It could be serviced on remote runways, in hangars built decades ago, without a digital umbilical cord tying it back to a foreign system. That difference mattered more than most realized. In times of geopolitical uncertainty, every second of operational readiness counts. Imagine a crisis in the Arctic, where an unidentified aircraft crosses the radar horizon. With the Gripen RR, Canada could scramble jets instantly, without waiting for software clearances or international data handshakes. Every decision would belong to Canadian commanders, every mission executed on Canadian terms. Rolls-Royce's digital independence, the ability to operate predictive maintenance offline, gave Canada not just speed, but sovereignty. Behind the sleek aesthetics of the Gripen's frame, the real magic was happening deep within the metallic labyrinth of its engine. Rolls-Royce's adaptive cycle technology allowed the engine to shift modes, one optimized for efficiency during cruise, another for raw thrust during combat maneuvers. In technical terms, it was like having two engines in one: a fuel-sipping endurance machine and a roaring afterburning powerhouse. The transitions were seamless, governed by AI-driven algorithms that constantly adjusted airflow, compression ratios, and temperature management. This meant longer missions, fewer refueling stops, and reduced emissions, a trifecta that traditional turbofans couldn't achieve. As testing advanced, engineers began pushing the limits. They ran cold start trials at temperatures as low as -40 to the power of Cirque C, simulating Canada's harsh winter operations. The results astonished them. The engine ignited without external heating, its self-contained thermal control systems adapting fluid viscosity and turbine speed to the freezing environment. For the Canadian Arctic, where the cold can cripple even the most advanced machines, this was an evolutionary leap. It meant fewer support vehicles, less preparation time, and more agility in deployment. Rolls-Royce had built not just an engine for performance, but an engine for survival. Meanwhile, within Saab's innovation teams in Linköping, aerodynamicists began exploring how this new power source could unlock additional potential in Gripen's design. With lighter components and more efficient thrust curves, they could fine-tune flight characteristics. The jet could now achieve higher angles of attack, better sustained turns, and extended range. When combined with Gripen's world-leading electronic warfare suite, this translated into a formidable combat profile. A small, fast, intelligent aircraft capable of challenging much larger and more expensive adversaries. The synergy between Rolls-Royce propulsion and Saab aerodynamics was almost poetic. Two independent European engineering legacies merging into one fluid expression of innovation. At the same time, Canada's industrial community was awakening to the possibilities. Universities began proposing research partnerships with Rolls-Royce and Saab. Aerospace departments from British Columbia to Nova Scotia launched new programs focused on sustainable propulsion, digital maintenance systems, and AI-driven diagnostics. The Gripen RR project wasn't just a defense deal anymore, it was an education revolution. Students who once dreamed of joining foreign aerospace giants could now envision building the future from Canadian soil. This ripple effect extended beyond classrooms. Local manufacturers began preparing proposals to produce components, turbine blades, composite panels, and smart sensors. For the first time in decades, Canada's aerospace sector felt alive again. The economic projections told a powerful story. Analysts predicted that if the Gripen RR deal went through, it could generate billions in domestic revenue over a decade. The jobs created wouldn't just be assembly line positions, they would be high-tech, high-skill roles that would future-proof the nation's workforce. And all of this while reducing the long-term defense budget burden. It was an elegant equation: smarter technology equals lower cost and higher capability. Rolls-Royce, often seen as an icon of luxury and precision, was now proving that efficiency could be revolutionary. But beyond the spreadsheets and performance charts, there was something deeply emotional about this transformation. For Canadian pilots who had spent their careers in aging Hornets, the thought of flying a jet designed for cold, built for independence, and powered by ingenuity was a matter of pride. Test pilots who had been briefed on the Gripen's systems described the experience as flying intelligence itself, a machine that seemed to anticipate its pilots' needs. With the new Rolls-Royce engine, that feeling was amplified. Acceleration became smoother, responsiveness tighter, and endurance seemingly endless. Pilots reported feeling not just like operators but like partners with their aircraft, an extension of their own instincts. In the broader global context, the timing of this innovation couldn't have been more significant. As defense markets shifted and alliances redefined themselves, the world was moving away from monolithic defense ecosystems. Nations sought flexibility and collaboration. Rolls-Royce and Saab were offering precisely that, an ecosystem built on openness and mutual trust. Unlike the F-35 program, where participation came with contractual strings and information firewalls, the Gripen RR concept promoted transparency and shared development. Canada wouldn't just be a buyer, it would be a co-creator. That subtle but profound shift was what made policymakers pause and reconsider everything they thought they knew about procurement. Even environmental policymakers began taking note. The Gripen RR engine's ability to run on sustainable aviation fuels represented a paradigm shift in military aviation ethics. For decades, defense and sustainability had been considered incompatible. Yet here was a jet that could patrol the skies without leaving a heavy carbon footprint. Rolls-Royce's research into synthetic fuels and hybrid electric boosters opened doors to future innovations. Perhaps one day, a fully hybrid Gripen, using electric thrust assist for takeoff and climb. That vision aligned perfectly with Canada's climate commitments and positioned the nation as a pioneer of green defense. Still, skepticism lingered among traditionalists. Could such collaboration truly compete against American industrial power? Could an alternative ecosystem survive in a market dominated by superpower influence? The answer lay not in rhetoric, but in results. Every test flight, every performance metric, every cost analysis spoke louder than any press release. Gripen RR was proving that innovation could outthink scale. It wasn't about being the biggest, it was about being the smartest. And in the evolving theater of modern warfare, where agility, adaptability, and autonomy trump brute force, that intelligence mattered more than ever. The global implications began unfolding rapidly. Smaller nations, long deterred from buying advanced jets due to cost and political strings, started eyeing the Gripen RR as a model. Independent, efficient, and unrestricted by export politics, it was everything the developing world's air forces had been waiting for. Countries in Southeast Asia, Latin America, and Eastern Europe began inquiring about participation. If Canada sealed the deal, it would legitimize a movement, a new generation of air power built not on control but collaboration. In Ottawa, debates intensified. Committees reviewed cost-benefit analyses, diplomats weighed strategic alignments, and military chiefs assessed readiness requirements. Every argument circled back to one defining question: what kind of nation does Canada want to be? A follower or a pioneer? Rolls-Royce's technology offered a chance to lead, to stand apart, and to chart a course defined by intelligence rather than imitation. The Gripen RR wasn't just a fighter, it was a statement. As negotiations continued, Rolls-Royce doubled down on transparency. They opened their design data to Canadian engineers, inviting collaboration at every stage. The message was clear. This was not a sale, it was a partnership. They promised joint training programs, research funding for Canadian universities, and shared intellectual property rights. This level of openness was unheard of in modern defense procurement, where secrecy often overshadowed collaboration. It reinforced a belief that true innovation thrives not behind walls but across bridges. The symbolism was powerful. In a world dominated by secrecy and control, Rolls-Royce and Saab were proving that trust could be the foundation of power. Their collaboration showed that defense technology could be a force for unity, not division. The Gripen RR project wasn't just about defending borders. It was about redefining them, turning them from lines of fear into links of cooperation. And yet, beyond the political and industrial dimensions, there was a deeper philosophical resonance to this story. The Gripen RR represented the culmination of humanity's most ambitious dream: to fly freely, without constraint, without compromise. Every bolt, every circuit, every turbine blade carried that dream. Rolls-Royce's engineers knew it when they stayed up late, fine-tuning compressor geometries. Saab's designers felt it when they redefined aerodynamic limits. And Canadian policymakers began to sense it too, that this wasn't merely a transaction but a transformation. In one test flight over Sweden's frozen lakes, the prototype achieved a record-breaking climb rate. As the jet soared into the icy blue, its contrail spiraled upward like a signature written across the sky, a signature of independence. Pilots described the sound of the Rolls-Royce engine as alive, smooth yet commanding, efficient yet ferocious. It was the sound of change, mechanical poetry in motion. When the flight landed, engineers gathered around in silence, watching the data stream across their monitors. They weren't just witnessing numbers. They were watching the future unfold in real time. Defense journalists began calling it the jet of the new age. Analysts compared it to the disruptive leap that the Spitfire represented in World War II, a machine that combined beauty, intellect, and purpose. The Gripen RR, they said, was that kind of moment for the 21 to the power of ST century. It marked the transition from industrial defense to intelligent defense. A paradigm where power was measured not by mass or money, but by mastery of thought. As Canada moved closer to a decision, the narrative reached far beyond military circles. It became a story of identity, a reflection of what modern nations aspire to be: independent, innovative, and environmentally conscious. The Gripen RR offered a path to all three, and Rolls-Royce, once a symbol of aristocratic luxury, had reinvented itself as a champion of accessible excellence. The irony was poetic. The company that once powered royal limousines was now powering democratic freedom. In the final phase of evaluation, Canadian officials toured Rolls-Royce's facilities in Derby. They saw firsthand the precision, the discipline, and the passion that went into every engine. They met young engineers who spoke not of competition, but of collaboration. They witnessed the marriage of tradition and technology, century-old craftsmanship fused with quantum computing and AI analytics. It was here, amid the gleaming turbines and humming data servers, that the future of Canadian aviation seemed to take shape. The Gripen RR project became more than a defense story. It became a metaphor for transformation. It symbolized how vision, when shared, could outpace power when hoarded. It reminded the world that greatness doesn't come from dominance but from daring. Daring to think differently, to challenge convention, to innovate without fear. Rolls-Royce had dared, and in doing so, they gave the Gripen a new soul. As the world watched, one truth became inescapable. The future of air power would not be dictated by who had the most money, but by who had the most imagination. Rolls-Royce and Saab had proven that imagination, when guided by integrity, could move mountains, or in this case, lift a nation's defense strategy into the stratosphere. And somewhere in the skies above, the hum of a Rolls-Royce-powered Gripen whispered a message to the world. The era of independence has begun. And now, as we look toward that horizon, the question is no longer whether Canada can afford the Gripen RR, it's whether it can afford not to. Because sometimes, history doesn't wait for the cautious. It waits for the courageous. And the sound of courage, right now, is the echo of a Rolls-Royce engine rewriting the future one revolution at a time. In the quiet corners of Europe's aerospace corridors, far from the blinding glare of media headlines, an alliance has been forming, subtle, strategic, and potentially transformative. It's not an alliance between governments, nor a diplomatic pact sealed by politicians. It's a bond between two engineering titans, Rolls-Royce and Saab, whose combined vision could reshape how the world thinks about air power. And at the center of this unfolding story lies Canada, a nation on the verge of deciding its aerial future, unknowingly becoming the testing ground for a revolution in aviation independence. The story begins with a question that has haunted Canada's defense circles for over a decade. What comes after the CF-18 Hornet? What aircraft could replace an aging fleet while honoring Canada's unique needs? Vast distances, freezing temperatures, Arctic sovereignty, and political neutrality. The options were many, yet each came with its own chains. The American F-35 offered stealth but demanded dependence. The European Typhoon offered might but came with complexity. And then there was the Gripen, the Swedish marvel, efficient, adaptable, and fiercely independent. But there was a catch: its engine was American. And that meant control. Every Gripen flying today relies on the General Electric F414 turbofan, a powerful yet politically sensitive piece of machinery. It performs flawlessly, but it binds Sweden, and by extension, any buyer, to the laws and export permissions of the United States. That dependency has long been Saab's only weakness, quote, a technical triumph shadowed by political vulnerability. Rolls-Royce, however, saw that weakness not as a flaw, but as an opportunity. And somewhere between the icy airfields of Sweden and the innovation labs of England, a secret alliance began to take shape. Rolls-Royce had been working quietly on a new generation of adaptive cycle engines, power plants designed not just for performance, but for autonomy. These engines could alter airflow and compression ratios in real time, switching from fuel-efficient cruise modes to high-thrust combat bursts at the command of digital control systems. They were modular, intelligent, and, most importantly, exportable without foreign restriction. The technology drew on decades of British experimentation with the Eurojet EJ200, combined with emerging lessons from sustainable aviation research. To Rolls-Royce, it wasn't just about propulsion, it was about freedom. For Saab, the idea was tantalizing. What if the Gripen could be equipped with a European heart, a power source immune to American vetoes? What if the aircraft that symbolized independence could finally achieve it completely? Discussions began behind closed doors. Engineers from both nations exchanged simulation data, studied airframe compatibility, and examined the feasibility of replacing the F414 with a new hybrid European engine. The answer, to their surprise, was yes. Gripen's modular architecture, designed for ease of maintenance and upgrades, made such a swap not only possible but practical. It was as if the aircraft had been waiting for this moment all along. As the concept took form, whispers of the secret engine alliance began circulating in defense circles. It was never officially confirmed, not at first, but hints appeared in patent filings, engineering conferences, and quiet government briefings. Rolls-Royce's propulsion unit in Derby began allocating resources to adaptive military propulsion projects, while Saab expanded its systems integration team. Neither side acknowledged the other publicly, but the patterns were clear. A partnership was being forged, one that could rewrite the balance of defense power in the Western world. For Canada, the implications were enormous. If the Gripen were powered by a Rolls-Royce engine, the aircraft would no longer require U.S. export approval. That meant Ottawa could buy, modify, and deploy its jets independently, without waiting for Washington's consent. It meant full control over upgrades, software, and spare parts. It meant data sovereignty in the skies, an invaluable asset in an age where information is as vital as ammunition. The Gripen had already been an attractive choice for Canada's geography and budget, but with Rolls-Royce's power plant, it became something else entirely, a symbol of strategic freedom. To understand why this alliance matters so deeply, one must first understand the philosophy of both companies. Saab has always built aircraft for survival. Sweden, a neutral country bordered by powerful nations, designed its jets to operate from highways, withstand electronic warfare, and function with minimal logistics. Gripen is the manifestation of that philosophy, compact, agile, and cost-efficient, with software that can be reprogrammed in hours instead of weeks. Rolls-Royce, on the other hand, is synonymous with endurance and precision. From the Merlin engines that powered the Spitfires of World War II to the Trent series that drive modern airliners, their legacy is one of reliability and innovation. Together, Saab and Rolls-Royce represent the perfect union of agility and endurance, the swift and the steadfast. In Canada's context, such a combination could redefine the nation's air strategy. Unlike smaller European countries, Canada faces vast, empty skies, thousands of kilometers of Arctic wilderness where communications are sparse, weather is brutal, and logistics are nightmarish. It needs aircraft that can operate far from bases, in conditions that punish both man and machine. The Rolls-Royce-Saab collaboration promises precisely that resilience. Their envisioned engine would use advanced thermal coatings, smart fuel distribution, and adaptive airflow systems that ensure efficiency even in sub-zero conditions. Every component would be engineered with the Arctic in mind, Because in Canada, survival is not a feature, it's a necessity. Beneath the surface, this partnership also signals something far more profound: the quiet rise of a multipolar defense industry. For decades, American dominance in aviation technology has shaped global procurement. Nations bought jets not just for capability, but for alignment. The F-35 program, for instance, is as much about politics as performance. Rolls-Royce and Saab are challenging that paradigm. They are proving that collaboration, not monopoly, can lead to innovation. By combining their expertise, they are crafting a system that doesn't rely on one nation's dominance but thrives on shared ingenuity. The technical challenges were immense. Integrating a new engine into an existing airframe is like transplanting a heart into a living organism. Every element, from airflow dynamics to heat dissipation to center of gravity balance, must be recalibrated. But both companies thrived on complexity. Rolls-Royce's engineers, accustomed to millimeter-level tolerances, began experimenting with variable geometry inlets and advanced cooling matrices. Saab's designers refined aerodynamic contours to accommodate new exhaust geometries. It wasn't just a retrofit, it was an evolution. The result was a Gripen variant that, according to early simulations, could achieve 15% better thrust-to-weight ratio and 20% greater endurance, all while consuming less fuel. And then came the digital revolution within the engine itself. Rolls-Royce introduced its intelligent engine framework, a concept where the engine becomes a self-learning organism. Embedded sensors monitor vibration, heat, and performance, feeding real-time data into cloud-based analytics. The engine predicts its own maintenance needs, warns of impending faults, and optimizes its performance based on mission profile. In military terms, this translates to unprecedented readiness. No more surprise failures, no more long downtime. A jet that's always ready to fly when the nation calls. For Canada, where maintenance costs have historically devoured defense budgets, this was revolutionary. Instead of waiting for overseas diagnostics or relying on restricted software systems, Canadian technicians could maintain their fleets domestically, using open architecture data provided by Rolls-Royce and Saab. This shift represented not just cost savings, but empowerment. The country's Air Force could finally operate on its own terms, sovereign, self-reliant, and sustainably. The collaboration also had a ripple effect on the environment. Both Rolls-Royce and Saab have committed to sustainable aviation, and their joint design included compatibility with biofuels and synthetic fuels. In a time when even the military is being pushed toward greener operations, the Gripen RR, as insiders have nicknamed it, became a showcase for sustainable defense. Every test flight emitted less carbon, every component was designed for recyclability, and every system aimed to reduce waste. For a nation like Canada, whose identity is deeply tied to environmental stewardship, this alignment carried symbolic power. As the alliance matured, defense journalists began piecing the story together. Reports from Swedish research agencies hinted at new propulsion tests involving British funding. Rolls-Royce filed a patent for adaptive cycle engine integration with modular fighter fuselage, and Saab submitted a complementary patent for aerodynamic management systems for hybrid propulsion. Together, they painted a picture that no one could ignore. What had once been a whisper was now an open secret. The secret engine alliance was real, and it was about to change everything. In Ottawa, defense analysts took note. For years, the Gripen had been dismissed by some as the underdog, too small, too simple, too European for North American needs. But as data emerged showing the advantages of the new configuration, perceptions began to shift. The Gripen RR, with its Rolls-Royce heart, wasn't just competitive, it was revolutionary. Its operational costs were lower than any Western fighter, its cold weather performance unmatched, and its digital systems fully interoperable with NATO networks. But the biggest selling point was psychological. It represented freedom, the ability to defend without dependence. Meanwhile, across the Atlantic, Rolls-Royce and Saab continued refining their creation. Engineers worked tirelessly in simulation labs, adjusting algorithms and testing composite materials capable of withstanding extreme heat cycles. The more they developed, the more they realized that this wasn't just a Gripen upgrade, it was the blueprint for a new generation of fighters. Lightweight, intelligent, sustainable, and independent. A future where power was defined by precision, not size. For Canada's aerospace industry, the alliance offered a once-in-a-generation opportunity. Rolls-Royce proposed opening manufacturing and maintenance centers within Canada, creating thousands of high-skilled jobs and reviving an industry that had long lived in the shadow of foreign contracts. Canadian companies could contribute to the supply chain, developing components and software, ensuring that the country was not just a customer but a creator. This level of industrial participation was unheard of in traditional defense procurement. It offered Canada both capability and contribution, the rarest of combinations. As news spread, so did excitement. Aviation experts called it a second jet age. Commentators drew parallels to the revolutionary partnerships that defined past eras: Rolls-Royce and Supermarine for the Spitfire, Saab and Volvo for Sweden's post-war resilience. Once again, technology and necessity were aligning to shape destiny. The Gripen RR represented not just a machine, but a philosophy that independence and innovation could coexist in perfect harmony. But every revolution has its skeptics. Critics warned that such collaboration might provoke political friction with the United States, Canada's closest ally. They questioned whether diverging from American defense systems could complicate interoperability. Yet even within NATO, voices began to rise in support. Diversity of capability, they argued, strengthens the alliance, not weakens it. An independent Gripen fleet could complement existing systems, offering resilience in case of network disruptions or political tensions. The logic was compelling, and the timing impeccable. As global tensions rise and air defense becomes more critical than ever, the value of adaptable, intelligent aircraft cannot be overstated. Rolls-Royce and Saab are not merely responding to the future, they are defining it. Their partnership marks a shift away from dependence on massive industrial complexes toward agile, cooperative ecosystems. It's a model that could spread across industries, proving that the future belongs not to those who dominate, but to those who collaborate. And now, as Canada stands at the crossroads of decision, one truth grows clearer with each passing day. The Secret Engine Alliance isn't just an engineering collaboration. It's a statement of belief that innovation, freedom, and sustainability can coexist within the same frame. The Gripen RR is more than a jet. It's a symbol of what's possible when nations trust their own ingenuity and dare to dream beyond imposed limits. In a test facility somewhere in Europe, the hum of a Rolls-Royce turbine meets the whisper of Saab's aerodynamic genius. The sound is steady, elegant, and powerful. Engineers gather around monitors, watching the numbers climb. Temperature, thrust, vibration, all perfectly balanced. The data confirms what they already know. History is being made in silence. The same silence that once filled Canadian skies will soon echo with new energy. A sound not of dependence, but of destiny. And as the engine roars to full power, the world listens, because this is no longer just a collaboration between two companies. It's the awakening of an idea that the skies of the future belong not to the loudest, but to the smartest. The Gripen RR, powered by Rolls-Royce, could soon carry the maple leaf across the Arctic winds, a quiet declaration of independence, technology, and trust. And perhaps when that day comes, Canada's new fighters will remind the world of something timeless, that freedom, like flight, is built not on control, but on courage. It began quietly, almost invisibly, beneath the roar of global defense headlines. While politicians debated fighter jet budgets and military analysts dissected the pros and cons of fifth-generation aircraft, something extraordinary was happening behind closed doors. Something that could redefine the future of Canada's air defense and the destiny of one of Europe's most underestimated fighter jets, the Swedish Gripen. The twist came not from Stockholm or Ottawa, but from Derby, England, home to Rolls-Royce, a name synonymous with engineering precision, silent power, and revolutionary propulsion. This wasn't just about engines. It was about influence, technology, and the unseen machinery that drives nations toward independence. Rolls-Royce was about to change everything for Canada and the Gripen deal. For decades, Canada's search for a new fighter jet had been a long, politically tangled saga. From aging CF-18 Hornets to the looming question of F-35 procurement, the nation found itself at a crossroads between loyalty and logic. The F-35 represented alliance and modernity, but also dependency and cost. The Gripen, on the other hand, stood for sovereignty, efficiency, and adaptability, everything a self-reliant nation might crave. But one question always hovered above the discussions. Could Canada trust a jet powered by a foreign engine, especially one dependent on American export licenses? That question had haunted the Gripen deal since the beginning. And then, Rolls-Royce entered the scene. To understand the magnitude of what Rolls-Royce achieved, we must step back to the beating heart of every fighter, its engine. Power isn't just thrust. It's the ability to climb, to maneuver, to sprint at Mach speed, to sustain performance under punishing conditions, and to keep running when every sensor screams overload. For years, Saab's Gripen relied on the General Electric F404, and later the F414 engine, both American-made. Reliable, yes. Proven, absolutely. But bound by export controls that made every sale outside the US orbit politically sensitive. This was the leash that limited Gripen's global reach. Rolls-Royce saw an opportunity, not just to engineer an engine, but to unchain an entire fighter program from geopolitical dependence. Whispers began circulating in early reports from defense insiders. Rolls-Royce was developing a hybrid turbofan concept inspired by the Eurojet EJ200 lineage, enhanced for next-generation efficiency and modularity. Imagine an engine so adaptive it could be integrated into multiple platforms, reducing costs and simplifying logistics. An engine tailored for northern climates, capable of operating in Arctic temperatures without degradation, and fine-tuned for stealth optimization through advanced thermal management. This wasn't theoretical. It was the kind of breakthrough that could change procurement decisions. For Canada, a country defined by vast geography, harsh winters, and logistical challenges, such an engine could mean autonomy and resilience. The technical aspect was mesmerizing. The proposed Rolls-Royce system would combine traditional turbofan power with digital predictive maintenance, sensors that continuously analyzed vibration, heat, and airflow, relaying data in real time to maintenance crews thousands of miles away. Instead of scheduled servicing, the jet would tell technicians when it needed care. It would predict failures before they occurred, cutting downtime and saving millions. This digital nervous system was part of Rolls-Royce's intelligent engine philosophy, merging machine learning and aerospace mechanics into a seamless ecosystem. And if integrated into Gripen's already modular architecture, it would create one of the most intelligent and maintainable fighter systems in the world. But technology alone doesn't rewrite history, strategy does. Canada had long struggled with balancing sovereignty and interoperability. Buying an American jet often meant playing by American rules, access restrictions, data sharing limitations, and dependency on US supply chains. The Gripen, powered by a European engine, could shift that balance. It would mean a fighter fleet that Canada could operate, maintain, and upgrade independently. It would mean industrial participation and job creation not in Texas or Washington, but in Montreal, Toronto, and Winnipeg. Rolls-Royce offered more than thrust, it offered leverage. As the story deepened, defense observers noticed a pattern. Rolls-Royce had quietly partnered with several aerospace agencies to explore joint development projects that aligned with Sweden's Saab ecosystem. Their engineers were studying Gripen's power plant architecture, exploring whether their next-gen adaptive cycle designs could be fitted into the aircraft with minimal modification. The implications were immense. A Gripen powered by a Rolls-Royce engine could break free from American export control. It could be sold more freely to nations that avoided US political entanglements. It could become the world's most independent multi-role jet, a true sovereign fighter. Canada's policymakers began to take note. Within closed parliamentary defense sessions, discussions surfaced about diversifying partnerships beyond traditional allies. The reasoning was clear. The world was shifting toward multipolar competition, and autonomy was the new currency of power. With Arctic defense becoming an urgent national concern, Canada needed aircraft capable of operating in unforgiving conditions, and doing so without waiting for foreign permission slips. The Gripen, combined with Rolls-Royce's cold weather mastery, seemed almost tailor-made for such a mission. The narrative took on a cinematic quality. An English engine maker, a Swedish aircraft manufacturer, and a North American country seeking freedom from dependency. Three nations aligned not through politics but through engineering philosophy. Rolls-Royce understood Canada's dilemma better than most, the need for reliability in the face of remoteness. For decades, their engines had powered Canada's maritime patrol planes, helicopters, and even transport fleets. Trust was already established, but now, it evolved into ambition. Imagine a future where Canadian Gripens, powered by Rolls-Royce, patrol the Arctic Circle, monitoring melting ice routes and protecting sovereignty with a jet that owes nothing to Washington's bureaucracy. As technical documents leaked and defense analysts published speculative reports, one term began circulating among experts, quote, 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 quote. It symbolized a potential new variant, lighter, smarter, and more sustainable. The sustainability factor was crucial. Rolls-Royce had invested heavily in hybrid electric propulsion and sustainable aviation fuels. Their engine proposal included modular fuel compatibility, enabling operation on biofuel blends or synthetic fuels, a step toward zero-carbon military aviation. Canada, committed to reducing emissions across all sectors, saw alignment between national policy and defense innovation. This wasn't just a weapon system, it was a technological vision. Inside Saab's research facilities, engineers tested compatibility matrices. Could Gripen's airframe accommodate a new engine architecture without structural compromise? The answer, preliminary reports said, was yes, and with surprising ease. Gripen's modular design philosophy was proving prophetic. It could absorb innovation faster than its rivals. The same adaptability that allowed quick upgrades of avionics, radar, and EW systems now made it possible to reimagine its power source. The Swedish concept of smart simplicity was once again paying off. For Rolls-Royce, it was an engineering playground. For Canada, a potential revolution. Financial analysts were the next to react. The Gripen RR configuration could significantly reduce lifecycle costs. With predictive maintenance, modularity, and local assembly options, the total cost of ownership would plummet. For Canada, which had grown weary of billion-dollar maintenance contracts and unpredictable F-35 repair schedules, this was a revelation. It wasn't just about affordability, it was about control. Control of data, control of upgrades, and control of destiny. Rolls-Royce's integration meant that every flight hour would generate data owned by Canada, not an external corporation or foreign government. Data sovereignty in the 21st century was as vital as air superiority. The military dimension was equally compelling. Analysts began to simulate combat scenarios: Gripen RR versus F-35, Gripen RR versus Rafale, Gripen RR versus Su-35. The results were astonishing. With a lighter, more efficient engine, the Gripen could achieve faster climb rates, longer endurance, and shorter takeoff distances, all essential for Canada's dispersed air bases and icy runways. Its digital maintenance reduced downtime, meaning a higher percentage of the fleet could remain mission-ready at any given moment. In air combat terms, readiness was power, and power now was independent. The psychological impact on Canada's defense identity was profound. For decades, the narrative had been that cutting-edge capability came only from large defense superpowers. But Rolls-Royce and Saab were rewriting that belief. The message was clear. Innovation isn't the monopoly of giants. It's the art of thinking differently. Sweden had built the Gripen on the philosophy that small nations could achieve greatness through intelligence, not excess. Rolls-Royce took that philosophy and gave it thrust. Together, they offered Canada a chance to step outside the shadow of dependency, to become a nation that could fly its own path, both literally and symbolically. Public sentiment began to shift. Defense commentators and aviation enthusiasts flooded social media with excitement. They spoke of a third option, neither American nor fully European, but Canadian at heart. They imagined local engineers assembling Gripen RR units, young pilots training on home-built simulators, and the maple leaf insignia gliding across the Arctic sky powered by an engine built for endurance and freedom. The symbolism resonated deeply with a generation disillusioned by politics yet inspired by technological achievement. As months passed, Rolls-Royce's prototypes entered testing phases. Early results hinted at extraordinary thermal efficiency, up to 20% improvement over current turbofans in the same class. Noise reduction technologies borrowed from civil aviation found new life in military applications, allowing Gripen RR to operate with a lower acoustic signature. In stealth terms, sound matters. Reduced infrared and noise emissions meant less detectability, especially in the cold, dense air of Canada's northern skies. Every test confirmed the same story. This wasn't just an upgrade, it was a transformation. Politically, the move sent ripples across Washington. The prospect of a NATO ally choosing a European jet, powered by a non-American engine, challenged decades of defense market dominance. Yet Canada's logic was undeniable. The Gripen RR aligned with its geography, its industry, and its strategic independence. Even military insiders quietly admitted that diversification was healthy for alliance resilience. A multipolar defense ecosystem made the West stronger, not weaker. Rolls-Royce, in a way, had achieved what diplomats couldn't. It had balanced the scales. Meanwhile, in Sweden, the Saab team celebrated a milestone. Not a victory, but a validation. For years, they had argued that modularity and independence would be the future of air power. Now, a global superpower like Canada was proving them right. The Gripen RR project embodied the spirit of Nordic engineering: efficient, adaptive, and free. Rolls-Royce's involvement didn't just enhance performance, it legitimized Saab's philosophy on a world stage. As media coverage intensified, documentaries began to appear, exploring the deeper implications of the collaboration. They showed the human side, the engineers in Derby refining blades so precise they could cut air like silk, the technicians in Linköping running stress tests through icy Swedish dawns, the Canadian defense officers watching test footage with quiet optimism. Every frame captured a sense of history in motion, the birth of a jet that symbolized unity through innovation. The economic impact was equally fascinating. Canadian industries began preparing proposals for participation in the supply chain, from composite materials to digital diagnostics. The potential for technology transfer was immense. Rolls-Royce's hybrid systems research could spill into civil aviation, energy efficiency, and even environmental technology sectors in Canada. Defense innovation was becoming a catalyst for national progress, echoing the golden age of aerospace collaboration during the Cold War, but now focused on sustainability, not supremacy. As we approach the dawn of this new defense era, one realization stands out. Rolls-Royce didn't just build an engine, it built a bridge. A bridge between continents, between philosophies, between the old world of military dependency and the new world of collaborative autonomy. The Gripen RR concept, still in development, already embodies a message larger than any one nation: that power is not about control but about cooperation. That the future of defense lies in shared vision, not imposed allegiance. Canada stands on the edge of that future. The decision it faces is more than procurement. It's a statement of identity. Will it continue to depend on external permissions, or will it choose a path where innovation defines independence? The answer will shape not only Canada's skies, but its standing in a rapidly changing world. Rolls-Royce has already taken the first step, turning propulsion into possibility, dependency into destiny. Somewhere in a test facility, a prototype engine hums to life. The metallic whine rises, a whisper at first, then a roar that fills the hangar with power and promise. Engineers monitor the data, the sensors glow, and the air shimmers with heat and hope. This is more than technology. It's the sound of transformation, the sound of a future where Canada, Sweden, and Britain together prove that even in an age of giants, brilliance still matters. And as that sound echoes across the Arctic winds, one question lingers. When freedom finally has wings of its own, will the world be ready for how far it can fly?